Please let me know if you can see my screen. Okay, so I'll assume you guys can see me. Right. Welcome to this session, everyone. We'll be speaking about problems covering revision 1, which are mostly, I think all of them are extracted from previous exams. So if you are able to solve these problems, it should give you a good idea on where you stand. Yeah, we'll cover most of them, and then whatever we don't cover, we can just do later for the interest of time. So here we have a question asking us to find the quotient and the remainder of the division of the polynomial 2x cubed plus x squared plus 2x plus 1 by x minus 1, right? So obviously, this is a long division question. And if you divide, if you take the first term here, which is 2x cubed divided by x minus 1, first you'll get 2x squared, right? 2x squared. And then when you multiply that back with the x minus 1, you have 2x cubed, right? So 2x cubed minus 2x squared. Okay, so that's what you have. And this is equal to what? Well, this is equal to, obviously there's two negatives here, so this negative 2x squared just becomes plus 2x squared. You add that to the x squared that is there. The x cubed term is cancelled, so you have 3x squared plus 2x plus 1, right? That's what's left there. And then next what you do is you divide this now by x minus 1, right? And when you divide that by x minus 1, you get, right, 3x, right? So you add 3x there. And the 3x multiplied by the x minus 1 just gives you, put this in brackets. The 3x multiplied by the x minus 1 gives you 3x squared minus 3x, right? So 3x squared minus 3x. And this gives you, obviously the 3x squared is cancelled. We left with 3x plus 2x, which is 5x plus 1. When you divide that, the 5x plus 1 by the x there, you get 5, right? So plus 5. And then when you multiply the 5 with the x minus 1, then you get, minus 5x minus 5, right? And this just gives you 1, right, plus 5, so which is just 6. So for our division here, we have that our quotient is equal to 2x squared plus 3x plus 5, and our remainder is just 6. So the correct answer is sub-question A. Any questions there? Okay, moving on. we look at question 2. And for question 2 here, we are given that cos theta, right? So our cos theta is equal to 2/3. And we're given that the angle theta is in the first quadrant, right? So if you could imagine this, you can sort of visualize it. Our angle theta is in the first quadrant, right? Because it's between 0 and pi/2. So pi/2 is there. And 0 is there. So our our theta angle belongs in this part here, right? And remember, this is the cos axis, and this is the sine axis. So using that, you know that the values of cosine and sine for this particular angle will have to be positive, because if you remember correctly, for all angles belonging to the first quadrant, the values of sine and cosine, and therefore the values of all the trigonometric functions, are positive, right? So since you know that, they're asking you to find sine of 2 theta. So there are multiple ways you can go about this. One way is to use the double angles, right? So you have sine of 2 theta. This is just equal to sine of theta, right? Multiplied by cos of theta, right? But you also remember that cos squared of theta plus sine squared of theta is equal to 1, right? So you remember that. Meaning that if you were to try to express sine in terms of cos, it would just be sine of theta is equal to the square root of 1 minus cos squared of theta. Okay, so right, so since you know this, you can substitute that into the double angle here, and you have 2 multiplied by the square root and then multiplied by cos theta, right? And you've already been given cos theta, which is 2/3, right? So this will just be 2 multiplied by the square root of 1 minus 2/3 squared multiplied by 2/3. And this will just become 2 multiplied by the square root of what? 1 minus 2/3 squared. 2/3 squared is just 4/9. So 1 minus 4/9. And that just gives you 5/9, right? Then the square root of that is just the square root of 5 divided by 3. And this is all multiplied by the 2/3, so this just becomes 4/9 multiplied by square root of 5, which is, yeah, option C. Okay, so that is how you would solve question 2. Now, moving on to question 3. we are looking at a function f of x that is given to us as, it's given to us as the square root of x plus 1 plus 4, right? And we are asked to find x when f of x is equal to 7, right? So if you think about it, one way you can solve this is by just equating in this equation here, just equating the left-hand side with 7 and then solving for x, right? But I think that's the quickest way you can solve this. So when you do that, you have 7 is equal to the square root of x plus 1 and then plus 4, meaning that the square root of x plus 1 is just equal to 7 minus 4, which is 3, right? When you square on both sides, you have x plus 1 is equal to 9, right? Meaning x is equal to 8. Right, so the correct answer here is just 8. Okay, so next, I'm trying to go through as many questions as possible before we get interrupted by load shedding or whatever. So next, we're looking at question 4. And question 4 is asking us for what values, right? Just give me a minute. Sorry, guys. Just give me a few minutes. Okay. Anyways, so we are asked to find the values of x for which the function f of x is equal to x squared minus 9 divided by x squared minus 7x plus 10 is discontinuous, right? So now, remember what discontinuous means. It means that you need to find all the values of x for which f of x is undefined, right? And if you look at the function that we're given, in your opinion, to find all the values for which the function is undefined, should we look at the numerator or the denominator?
Denominator.
Right. Thank you. So we look at the denominator. So we look at all the values for which, well, basically, and all the values that make the denominator 0, because those are the only values for which the function would be undefined, right? So you basically have to solve for x, right? And this is a quadratic equation, right? So if you look at finding delta, it's just going to be equal to what? It's going to be equal to negative b, which in our case is 7, right? That's all minus, sorry. plus or minus the square root of b squared minus 4ac, right? So b squared is 7 squared, which is 49, minus 4 times 1 times 10, which is 40, right? All of that divided by 2a, which is 2 times 1, so divided by 2. And here you get two values, right? You'll have 7 plus, right? If you look at the positive option first, 7 plus the square root of 49 minus 40 is just 9, so the square root of 9, which is 3. So 7 plus 3 over 2, which is 10 over 2, so that's 5. And if you look at the negative side, you have 7 minus 3 again, so that's 4 divided by 2, which is 2, right? So those are the two roots.
That's some
Sorry?
formula we should know.
Sorry?
Is that some formula that we should know? That sigma, I don't know, that sign thing that you have there. Yeah.
Okay, sigma is just delta. I think you guys, how do you solve for quadratic equations? I think the formula is
it's a quadratic formula.
Yeah, it's a quadratic formula. Negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? You guys know this, right?
Yes, we do.
Yeah. So that's what I'm applying here. It's just that you guys might be more used to, the other delta. I think the default is, you guys might be used to this form.
Yeah, no, it is bad.
Yeah. It's the same thing. It's just that in words, I think the default is the other form. But this is what you're doing. So you're basically solving for the zeros of the quadratic equation. Right. So now that you have that, so you have the two values, the two zeros, these two values make the quadratic equation in the denominator 0. And those are the two values that would make our function, right, which is the original function here, discontinuous. So the correct answer would be D here. Right? Okay. Now, just give me a minute. Keep getting messages. Okay, so looking at question 5. So for question 5, this one, we did it yesterday, but I'll just repeat it here because it's an important one. It sort of lets you know how you should think about solving these types of questions. So obviously in the exam, you guys will deal with the entire content, right? Everything you've seen from the beginning of the semester up to the end, right? So when they give you a question like this, right? Contrary to what you guys were doing in the test, so in the test, you know, for example, that if up to that point you hadn't covered, let's say, the integrals, right? Then you know whatever question you get in the test won't require you to use the integrals because you guys haven't covered that, right? But in the exam, it's different because you guys have covered everything now, right? So you can use whatever methods you have covered in the lectures to solve the problems, right? So that's one distinction that you should make between what you guys were doing in the tests and what you'll be doing in the exam. Another point that is very important is that based on how you choose to solve your problem, you should see if, especially for this first revision file here, as you will see, most of these questions are multiple choice questions, right? And what they used to do is in previous exams, is I think the first section of the exam is just multiple choice questions, about like 10 or 15 of them, right? And then there's like some more other questions concerning integrals, limits, derivatives, what and whatnot. So functions and stuff like that. But that comes after the first main question, which is mostly MCQ, multiple choice questions, right? And for multiple choice questions, you should know. So for multiple choice questions, you should know that if you're trying to solve a question and it takes you 15 minutes, 15, 20 minutes to solve the question, you should definitely know that you're going about it the wrong way, right? Because these multiple choice questions are made for you to be able to quickly find the solution without having to like go through a lot of like steps, right? That consume a lot of time that you guys don't have. So you need to know that if they've included this question in the multiple choice section of the exam, then it should probably be a question that you should be able to solve in 10 minutes, 10-minute maximum, right? Nothing above that. So this is one such question. So if you look at question 5, you're given that the derivative of f of x is x over x squared plus 1. And you're given that g of x is equal to the square root of 3x minus 1. And they give you that big f of x is equal to the composites of f and g of x, basically f of g of x, small f of g of x, right? And you're asked to find big F prime of x, right? So there are two ways you could go about this. So first, you will need, in both ways, you'll need to find, right, what is, well, okay, so if you go about it the first way, let me just say this. If you go about it the first way, what you would do first is you would try to integrate the f prime of x here, right, to find f of x. Because remember, right, if I can just write it down. So if I call this the first way, so you know that if you're trying to find f of x from f prime of x, all you do is just you integrate. So you use the integral. So you just integrate f prime of x and you find f of x. Right? So you guys know this. But now, if you look at the equation that we're given here, right? It's x over x squared plus 1, right? So you would have to, right, take the integral basically of x over x squared plus 1, which, as you can see, is not a straightforward integral. So you have to do some manipulation to get to the solution, right? But as soon as you do all of that, you use all the methods that you guys know to solve integrals, right? And then you find your final answer. The next step would be, then you substitute g of x into f of x, the function that you found, and immediately you have found the big f of x. And then you just take the derivative of that and you find whatever the answer is, right? So that's the first way. Now, the second way to think about this is by using what you guys did when you were looking at derivatives. So you will use the chain rule. So the first way is integration. The second way is the chain rule.
Jonathan?
Yes?
If we use the first way,
Yeah.
from the integral, we'd have inverse of tan x, right?
No, it can't be inverse of tan x, because the derivative of tan inverse is 1 over, yeah, so it can't be that.
I didn't see the x in the numerator. It's okay.
Yes. So probably would it would be ln, right? It would be some sort of ln of x squared plus 1 divided by 2, right? But then again, as I said, it's not something that you can clearly see right away, because you might remember that in the exam, you're trying to solve these questions quickly, right? And it's the MCQ section. Please mute yourselves, please. So if you're trying to find, to solve these MCQ questions in an exam, they don't ask you for the methods. So you can just use whatever method you want, right? So the first way would have you first find the integral of the function, the derivative of f of x, then substituting g of x, then deriving, right? Again. So then the second way, you would just use the chain rule that you guys are familiar with. And the chain rule tells you that if you have big f of x is equal to small f of g of x, using the chain rule, when you take the derivative of b of x, you just do what? You take the derivative of the outside function, which is small f of x, right? Multiplied by the derivative of the inside function, which is small, which is g of x prime, right? Okay, sorry, just let me. So, right. So, and then you so using the chain rule, you take the outside derivative of outside function multiplied by the derivative of the inside function, which is g of x, and then multiplied by the derivative of just x, which is 1, right? So it would be 1 multiplied by 1, right? So that's your chain rule, okay, if you remember it. Now, this first part here of the derivative, right? The first part of the derivative, which is f prime of g of x, is just g of x substituted into f of x, f prime of f of x. And you're already given f prime of f of x, right? It's x over x squared plus 1, right? X over x squared plus 1. But now you just substitute wherever you see x with the square root of 3x minus 1, right? So you have an x in the numerator. You just substitute that by the square root of x, 3x minus 1. You have an x in the denominator squared. You just substitute that with the square root of 3x plus 1. Sorry, minus 1. And then what you get is, if you were to rewrite this, what you get is in the numerator, the square root of 3x minus 1 stays. In the denominator, the square here just becomes 3x minus 1, right? And this is then equal to, once again, let me just copy this. This is equal to, the minus 1 and the 1 will just cancel. So in the denominator, you'll just have 3x left, right? So that's the first part of the derivative. Then the second part is just taking the derivative of g of x, right? So taking the derivative of g of x, you just derive the square root of 3x minus 1, which is equal to what? So I want you guys to tell me.
It's going to be 3 over 2 roots 3x minus.
You said 3 over 2?
3/2 times root 3x minus 1 in the denominator.
Good. Okay. Does everyone agree there? Yeah, I'll take your column as I see a hand risen. Is it a question or do you just agree with what she said? Okay. Well, just feel free to stop me if you have a question. Okay, so then since you already have your g prime of x, now you just go back to your original expression, right? Which was f prime of x, right, is just equal to f prime of g of x, which you found to be the square root of 3x minus 1 divided by 3x, multiplied by g of x, which we found to be 3/2 roots 3x minus 1, right? Put a bracket there. And all of that multiplied by 1, I'll just take it out, right? And then obviously you can see that the square root of 3x minus 1 will just cancel. So you will be left with, and the 3 as well, right? So the 3 will cancel and the square root of 3x minus 1. So you'll be left with 1 in the numerator divided by the 2 here multiplied with the x. So 1/2